So if you take the diagonals this way and multiply all of those numbers, you would get 10 and 6 and negative 8. And if we went backwards and did these three diagonals, you would get 60 plus 1 plus a minus 8. All of these ones added up together give you 8. All of these ones added up give you 53. And it's the blue ones minus the red ones, so 8 minus 53 to get a determinant of negative 45. That's using the arrow method. You could have also done the formula and got 45 as well. But I find the arrows way easier to remember than using the formula. So me personally, I never use this formula. I always use the arrows. Is anybody writing the formula stuff down right now, or can I keep going? Yes? Maybe? Everybody good? Okay. So when we are doing inverses, the formula to figure out the 3 by 3 inverse is super complicated. I'm going to teach you a method later that is easier than a super complicated way. However, right now, the main formula for figuring out is super complicated, so we'll always use our graphing calculator for this. And again, if our determinant is 0, you cannot find an inverse. So, given the matrix P, determine a value of x for which P inverse doesn't exist. In other words, if it doesn't exist, that tells us our determinant is equal to 0. So I'm going to rewrite column 1 and rewrite column 2. And then, or you could use the formula. I'm going to erase that. I'm going to say, no, you're not even going to think about using that. Then your determinant is the blue ones minus the red ones. I'm not even going to show you the other formula. And then it's just a matter of solving for x. Apparently, if x was negative 14 over 3, things would be bad. And the determinant would equal 0. And once that determinant is 0, you cannot find the inverse. So take out your graphing calculators. And we're going to type these into our calculators. We're going to type in A and B. So go to our calculators, go second matrix, edit A, make it a 3 by 3 if it's not already. And we're going to enter in these values. 1, 2, 0, negative 2. Oh, I got to hit the negative button. Negative 2, 0, 1, 1, 3, 4. And I'm going to go over and edit B. Also make it a 3 by 3. 1, 1, 5. Negative 4, 2, negative 7, 4, 7. Perfect. And if we write matrix A and then hit the inverse button, it will find the inverse for us. If there's like lots of decimals, of course you could arrow over to see them all, but if you hit the math button and change it to a fraction, it is much easier to see. So if we type things into our calculator, we can get A inverse. And once we have A inverse, we can find another matrix P. So if you multiply A times P, you would get B. So since there's not dividing in matrices, right? In normal math, if you wanted to get P by itself, wouldn't you divide both sides by A? And you would say P is equal to B divided by A. But dividing doesn't exist in matrices. Instead, we have inverses. And when you multiply by an inverse, you get the identity matrix. And the identity matrix is the matrix that's like a 1. You multiply it by anything and you get what you started with. So by putting an A inverse in front here, it would hit the A and make a 1, or an identity matrix. In other words, get P all by itself. Again, with matrix multiplication, order matters. So if you put the A inverse in the front of this side of the equation, you have to put the A inverse in the front of B. So our math looks like this. A inverse in front, A inverse in front, that would get P by itself as A inverse times B. And since we have those things both in our calculator, I can go to my calculator, I can type in A inverse and multiply it by matrix B, and it will show up as the answer. Yes?
Just a little weird question. Are you able to put matrices inside of matrices?
Like, while you're doing your list of matrices, you put a matrix inside in a certain part. It gets a little bit tricky because then what are the dimensions of that, right? Because if I have a 2 by 2, and in one of those elements I throw a 3 by 3, now my matrix doesn't have any kind of dimensions because I've got like a sub-matrix inside. Now, that being said, if you wanted a matrix to hold matrices, technically it's for holding data. You could theoretically do something like that. Just a lot of your math might not be doable based on what you have there. Push enter. I'm really curious right now. Do you think we need that time sign, or do you think the calculator would know? It would know. Let's do, oops, that's letter D. Alpha matrix. No, that's still letter D. Second matrix, A, inverse, and if I just did B, what a smart calculator. And sure enough, that is our answer for P. Which is way better than having to try to guess and check. Because can you imagine multiplying two things and be like, I need this to rotate and crash and add up all those pieces and hopefully it works out with this number and this number and this number? I think that would take a long time. Yes.
When we're doing work isolating with matrices, are we allowed to, because I know that you told us that we don't really divide, we just multiply by inverses.
Yeah.
Are we allowed to divide but then change what was divided to just a power of the regular term at the end?
So, like, I know what you're saying. You're like, you want to do this, right? right?
Yeah, are we allowed to do that?
I'm gonna say no. And the reason I'm gonna say no is how do you know from here to go to this as opposed to, like,
Right.
how do I know? Because if my original question was PA equals B, you still would show this work. But this one, the A inverse would be the second one. Because it would have to happen after. So I don't like it for that reason. I would like it because here you're showing that you're inputting the A inverse in front, which means that that A inverse has to be in front there. I mean, technically, using rules that don't exist for matrices, it works. But since there is no dividing, we shouldn't really show dividing. Because you're technically using something that doesn't exist temporarily just to get back. And this is someplace that is really nice to have matrices. Because a system of 3x3 equation, we did systems of 2x2 yesterday, and despite my mental math blunders, it was still quite a bit faster to solve than if we solved it with matrices. But you've solved 3x3 by hand before, and they're kind of annoying. Because first you decide, okay, what do I want to eliminate first? Am I going to eliminate x's? And you choose two equations to eliminate the x's. And then you get two new equations with just y's and z's. And now you're down to a 2x2 and you solve for that, and then plug everything back in. So again, what we're going to do though is we're going to set up a matrix equation where matrix A is all of our coefficients, matrix X is all of our variables, and matrix B is all of our answers. And if we put these into our calculator, we can set up our equation, multiply by the inverse in front, and we would know that x is equal to A inverse B. And if we type these things into our calculator, it's going to give us the answer, which is really cool. So I'll freeze it here so that you can keep writing if you'd like, although you have basically, it's not hard to take the notes and do it. And we're going to go to our calculator and edit matrix A. So I'm going to just, while you're writing that down, I'm going to put it into my calculator here. So there's matrix A. Matrix B is now 3 rows, 1 column. So I've entered them into my calculator here, and I can just type A inverse B, and because A inverse is also square matrix 3x3, and B was a 3x1, the middle numbers are the same, and I should get a 3x1 in the end, and sure enough, my 3x1 in the end are my values for x, y, and z. So x has to be 4, y1, z1. You can check it. 4 plus 2 minus 3 is 3. Good. 4 minus 1 is 3. Minus a negative 1. No, plus a negative 1 would be 2. Yeah, that one works. And then 8 plus 1 is 9. Minus 1 is 8. Look, all three equations work. That was pretty slick. So I'll get you to try the second one on your own.
extra one would be custom.
So in B, when something's missing, makes sense that you put a 0 in there. That was successful? Excellent. All right, we'll stop video 1 here for today.